How about now? Can you still see my screen? Guys?
Yes, ma'am.
I can see you, ma'am.
Okay.
Same
It's
for
good because I cannot see you. So today we're going to discuss about color theory and composition, mainly because of color. So our topic today is about color. And we're going to see what is the function of color, how does that change when you put it in a composition, or how does it change when you put it um in a paper, how does it differ when you're looking at it in a computer or in a piece of paper or canvas. So we will also discuss uh, how do you mix colors. Mix colors, I mean, when you put different colors side by side, how do you um, what color suits together, or how does contrasting colors, how are contrasting colors good and differ to colors that blend together. So where's my mouse? Okay, so anyway, so color is a perception. It is something our eyes see. So it is from the light, and then the light that refracts. The, the color is the light, and then it is something that we see, and the light that we see, it our eyes would like process it, and that data will be sent to the eyes, to our brain cells, and the brain will tell us what kind of color that is. So um, different objects reflect different light, and different objects also absorb different lights. Different objects can also be different combinations of light wavelengths, and our brain would pick these wavelengths and combinations, and our brain will translate them into a phenomenon called color. So color, therefore, is perception and a phenomenon that we see. So this is we have two color mixing models. You have the RGB and the Cmyk. So how is this different, and how is this significant to our class or to our course? Well, RGB and wait lang, ha? Right. So RGB is the color that we see in TVs, screens, projectors, and this primarily use green and blue. So that's why you have blue light glasses to help you see things better. So mainly the RGB color mixing model is the theory of how light, different kinds of wavelengths in light is wait lang. different different colors uh different colors come from light, and how you separate these colors, or how you separate light, that would be your RGB color mixing model. So imagine a prism. So when you if you direct a white light into a prism, and and then the prism um would would the outcome of the prism, at the end of the prism, you will see a spectrum of colors. So from this experiment, you can see that the white light is the pure color or the pure light, and that from it comes the different colors. So from this RGB color mixing model, it means that if you're going to mix green, blue, red, you're going to come up with white and not black. So this is how you are going to mix colors using light. So um, so that's why if you are going to mix different colors, for example, red neon or any kind of, for example, any kind of, well, it's Christmas lights, any kind of Christmas lights, if you mix them up all together, more likely the whole light, the light in general from afar would look like white. So that is your RGB color mixing model. And then you also have your Cmyk. This is what we call the subtractive color mixing model, in a way that it is the opposite of the RGB. So this is where we use with paper on canvas, because we use pigments, right? We use watercolors, we use acrylic. So we actually add something or an object to the paper. So in a sense, when we add up different kinds of color, we, instead of getting the white light, we are making things opaque, and therefore the light from the paper, or light coming from the paper or reflecting from the paper, will be not will not be allowed to pass through. In a way, it we are subtracting the light from the paper using these pigments. So so that is why when you add magenta, cyan, yellow, we would what the result would be black. So that is why we say printing is a subtractive method, or CMYK is a subtractive color mixing model, and stuff like that. So, okay, do you have any questions?
No, ma'am.
Okay, so this is a Yumber wheel. So there are different kinds of color wheels, but this is specifically designed. No, I mean this diagram is designed to let you see the difference between what is digitally created and what is hand painted. So on the left, you have the digitally created one. This is the RGB color mixing model, and the right is a hand painted Yumbu wheel, which is which uses the CMYK theory or color mixing model. So if you can see here on the left, um, things are very, very smooth, right? And it be- and it's very, very clear, and it's also, and the yellow, I mean the tint or the color is very, as it at the end of the color, I mean of the grid, you can see that it is vibrant, and at the end it becomes whiter and grayish. But if you could see on the right hand painted Yumber wheel, you could see how it is also gray. It is done to mimic the digital created one, but as you can see, it is very difficult to actually mimic the digitally created Yambri wheel. Why? Because as you put it's as you make the color grayish or more dark, it would look like um gray, or it would mute the color, or it would rather make the color very, very dark if it is. That is why the gradient for the red, for the magenta, for example, and the hand painted Yumbre wheel is not as smooth than the digitally created one. So, uh, fun fact: the color wheel itself was designed by Sir Isaac Newton in 1666, and he actually did this to highlight the different refractive or the reflective colors of or the different wavelengths of light. So he used it to map the light. So, but artists use the color wheel to develop color harmonies, mixing, and palettes. So there are different kinds of colors. You have primary colors, you have secondary colors, and you also have tertiary colors. So what are your primary colors, guys? Do you know?
Primary colors, ma'am?
Yes.
Red, blue, yellow.
Cool. Okay. And then what are your secondary colors? Guys, anyone? Does anyone know what is
Purple, orange, green.
yes? So how do you get the oops, how do you get the how do you get secondary colors? Where is it from? Yes, can you tell me? I cannot see your um, I cannot see your wait lang. I'm going to get my iPad. I cannot see your comment. What did you say? How do you get your secondary colors? Guys? How do you get your secondary colors? How do you get your secondary colors? By Joe.
Hello po, rinig na po ako.
Yes.
By mixing the primary colors po, ma'am.
Yes, that's true.
Hindi
So
po kasi ko rinig kanina. I'm so sorry po.
okay, so when you mix red and if you mix red and blue, what do you get? Yes, Catherine.
Purple po.
And then when you mix yellow and red. Yes, Vaijo.
Orange po.
And when you mix blue and yellow. Yes, Diana.
Green po.
Very good class. So, how do you get your tertiary colors and what are your tertiary colors? Anyone? Yes, Vaja.
By mixing your secondary colors na naman po. Tas yung, ang alam ko po, there are 6 tertiary colors po. Red, orange, yellow, orange, blue, violet, blue, green, yellow, green, and red, violet. And
Very good. Green, you forgot the green. Green, blue, green.
blue, green po. Pati po yellow, green.
Yeah, right? Ay, di pala. So, okay. You have your warm colors and your cool colors. So the warm colors are your red to yellow, and your cool colors are your violet to yellow green. So when you say warm colors, it signifies energy, brightness, action. And when you um, when you look at cool colors naman, it signifies calm, peace, and serenity. All right? And this would also be significant later. So you have your hue. Your hue is the what you also call the pure color. So that is the hue. Pero if you add black, that is the shade. So hue plus black, that is the shade. And then your tint naman is different from the shade because instead of adding black, you add white. So it would look like pastels. So that is your tint. And your tone, that is the grayish counterpart of your color. So, all right, black, shade, tint, white, and tone, gray. All right. And you also have dimensions of color. So, hue is the thing, is the color that is the edge of the color wheel, right? It is the true color. Chroma naman is how pure or grayed down it appears. So this is your shade. No, not shade. Your tone, right? It is from the shade and the tone, or the tone to the shade. That is your chroma. It is how pure or grayed down it appears. So it basically is like this one on the right. I don't know where my pointer is, but okay. So on the right figure, that is your chroma. You could see the chroma, how the color goes grayish or going to its shade or to darkest. You also can see there how your value, that the value is the lightness or darkness of, the darkness of the hue or the color. When you say chroma, it is the darkness, and when you say value, that is the lightness. Okay. So this is the difference between. There are different kinds of from the UV wheel earlier today. You can see how it is very hard to mimic the colors in real life or mimic how how you see it in photographs and how you're going to paint it. For example, the red neon is trying to mimic the red neon is very hard, and this is the example, and this is why. Because the effect of the eye cannot be mixed with the pigments, for example. If you're going to see red neon, you're going to see red, yellow, and a little bit of orange, and it also has to be light. I mean, it could also should be bright, right? It should also have an effect of that is it there is light coming from it. But neon color is the lightest value of a color, but with red neon, it's very hard because the white oil character plus pure red, it um it gives a misvalue of the correct color of how you're going to see it or you're going to paint it. So for example, here on the left, that is your picture. On the right is your uh, painting. So you can just imagine how hard it is for the painter or for anyone in particular to make the red neon very bright compared to on the left. Sorry. So what is local color? So local color is the color of the surface of the object that is very close to white light. So here your local color, here is that one that is close to the white light. Wait lang. So you can see my mouse. Can you see my mouse now? Okay. So okay, so this is your local color here. It is color that appears close to white light, so that is also your tint, right? Oops. And then how about here? The local color here is where? Can you tell me where? For example, on the balls, where is the local color here? Guys, are you there? Guys, let me just reiterate that. So color, local color is the color of the surface of an object as it appears close to your white light. So basically, your local color is the color that is almost white, but not very white. It is so ibig sabihin nito, it's the color that it's supposed to be, for example, red, but it's not red. There you can see how it's kasi local color is usually the color that hits the light or reflects the light. So that is why when you color it, it looks like white or bright, really, really bright red, for example. That is your local color. So your local color is different from the color, its usual color. I mean, for example, here on the bus, you can see there's a red stripe. The red stripe doesn't look flat red. It has different kinds of red. So the local color there is the one on the top edge of the red. So that is your local color. It's the one that hits the light. Do I make myself clear?
On the yellow part din po ba, ma'am, ng van? Local
Yes.
color din po ba yan?
Yes. So basically, the local color is not always red, but rather it's the color that is hit by the light that makes it really white, or in other words, it's the tint. It's the lightest shade of that color. Do you get it?
Yes, kinda.
Kinda. I'm not. Okay, what is your other question? So I could make myself clear.
Ang example po, ma'am, dun po sa blue po. What if po that color is sky blue talaga? Like, hindi siya po na-hit ng light. Is that local color po or hindi?
So, not?
So, para pong yung local color, it adds value to the drawing at some point.
Yeah.
Oh, yeah. Okay. I think I'm getting na po.
So, for example, here in the top part of the bus, you have this sky blue, right, color. But if you could see on near the bump, on the left side, there's the light. Here, you see it here. This one is your local color. This is the highlight, and this is the local color. So you can see the dark area here, the shaded part, and you also have this lighter shade of sky blue. So that is your local color. Do you get it? Is it better? Guys?
Okay na po, ma'am.
Okay.
Same for me.
Okay. I'm glad that I was able to explain it well. So it's also the same as this one. So the local color here, for example, let me just show it like this. So this is your highlight, and the closest color there is here, right? The gray. And also here, you also have red. This is your highlight, and this is your local color. Same thing with here. This is your highlight, and the subdued white color is your local color. Same thing with here. This is your shadow, right? This is your core shadow, and this is your highlight, but this is the local color. The lighter area that's not very close to white, or not basically white. So I am. Well, it's not really white, but so you could also call it your local colors. So you also have your grays and your neutrals. So your grays and neutrals are also very important. It's not always red, yellow, blue, or it's not always contrasting. There is also a very good, you could also provide a very good painting with only just grays and neutrals. The gray color and the neutrals would make a very contrasting background, or it would also make uh, the contrasting color, like for example, red and blue here, very emphasized in this composition. So that is also very good to use grays and neutrals. And also, grays and neutrals can also provide a very reflective mood. And grays could also come in very subtle variations. Like, not all grays are, black and white gray. You could also use reddish gray, for example. Remember your tone and shade. you could use those colors. You could also mix them up. Like for example, this um sample here, you have the red here. This is your local color, and you have the grayish part here, and also this one. But you can see there's a highlight of, or there is a pigment mix that looks like red or gray, red or yellow, sorry. So that could also be called as your tone or gray or neutral. All right, not all grays and neutrals are really gray. Some can be mixed with different kind of color. And you also have your gradation. Gradation. So gradation is from light to dark, dull to a very saturated one. So on the left, on the on the topmost picture, you have a very very light color, and then on the bottom you have a very very dark set of trees. Right? It's what we call gradation, and it is also the same as on the right side picture, but here you could also see how the light or the sunset is very dull yellow, so tinted yellow, and then slowly it would become very, very saturated in color, red, yellow, and greens or brown, for example. So that is your gradation. And you also have tints. So I remember when we talk about tint is um, hue plus white. So it would look like a pastel color. So example of tints are a hazy day, paler ranges of color, and then also with tint, you could also convey a feeling of light. And in order to paint a pastel color like this, there are two ways that you could do it. You can add white, or you could apply a thin transparent layer of white over to make your color a little bit whiter or a little bit pastel. So that is your tint. And your tint is also very good, just like the grays and the neutrals, because it is very good to partner with a vibrant color, because it would make your color very contrasting, and it would give emphasis to the color, just like this one. So here we go with complementary. So complementary colors are two colors that are opposite to each other. So for example, orange and blue, or what else? This color wheel is not really precise, but you can see naman yellow and violet, for example, could also be complementary, or yellow and blue, green and red, for example. So that is your complementary colors. And complementary colors are really, really good to also use, especially in a logo design, because it can bring out the design, or bring out the colors, make the colors pop, which is very needed when you make a logo. You want to make your logos pop. So, for example, this one, you have pepper powered logo. This is designed by Real. for pepper power. So if you can see how contrasting colors or complementary colors work with each other. You also have your analogous colors. Analogous colors are three colors that are side to side in a color wheel. So you have blue, blue violet, and your blue green, for example. You could also choose red, orange, and yellow, for example. So basically, analogous colors are colors that are side to side in three colors that are side by side in the color wheel. So, for example, this one, you have the Frito-Lay and the Tostitos. So, on the top, you have the gradient of yellow, red, and orange. And on the bottom, you also have blue, dark blue, and well, it's actually a tint. It's a shade, but okay, you have your Frito-Lay. So it makes a very striking website, right? Because of the color. And it also makes a striking design because of the color. And then you also have your triadic color. So these are colors that are three colors that are equally spaced around the color wheel. So you have your red, blue, and yellow, for example. But you could also twist the triangle a bit and also use different kinds of color like violet, green, and orange, for example. You could also use that to your advantage. So basically, it's just three colors that are equally spaced around the color wheel. For example, you have this one, Burger King. I think everyone knows what Burger King is, so I like burgers so anyway. It's very hard if you don't know Burger King, but well, Burger King from the name burger, it's a logo for burger and burger. Anyway, you have the red, yellow, and blue. So that is your yeah. I also love their burgers and fries, but well, I also love burgers and fries in general. So um, you have your red, yellow, and blue, and on the color wheel, that is a triadic position. So there. You also would use this on marketing, branding, and sales. So this is how you use your color theory. This is what, guys? What is the colors used and what is the scheme used in this web page design? Can anyone tell me? Voila. All right, so let me give it a first go. This website design is monochromatic, but it also uses different kinds of color blue. So if you could see here, there is a shade of blue, there is a tone of blue, there is also a tint of blue. So it's a gradient full of blue. It's different kinds of blue, right? And as you can also see here on the left side, you can see a little orange there. So it actually made the hat more emphasized because of that color orange, which is actually the opposite color of blue or complementary to blue. Also, this is neutrals, right? And then this one, contrast yellow, right? And then now you have your color context. So how color behaves in relation to other colors and shapes is a complex area in color theory. So without reading the text below, can you tell me what you see on the group of colors here, the boxes? Guys? Yes, Vaidra.
So depending on what the small red box, so yung color ng background niya, it's kind of changing. Like in red and black, it's so vibrant, but not that vibrant like the red and white. Then when you go to red and orange, it's like the red was camouflaging at some point. Then we have this kind of contrast red and blue. But it's kind of weird for me when I see that red and blue. It's a weird combination for me. I hate it. But yes, that's for me, man.
So that's true, actually. So red appears more vibrant or more brilliant in black background and duller naman against the white background. I-compare mo yung white and black background, the red pops up more with the black background compared to the red, to the white background, but it looks lifeless in the orange. It looks like it's blending or something in the orange background. While on the blue-green background, it looks very brilliant and contrasting. But if you compare the blue-green and the black background, the red looks more bigger on the black background compared to the other colors. Am I right? Guys?
Yes, ma'am.
Okay.
Yes, ma'am.
So how about this one? What do you see? Yes, Catherine.
Ma'am, from what I understand po, it's more of a monotone color kasi when we say the monotone, it's one color but they have different shades. So from what I see po on the left side, there's light purple while the other purple it's getting dark. Something like that po.
Well, actually, that is true. So the colors that you see on, even if the two colors on the middle are the same color, it is the same color, but the color in the background can influence the color that you see. For example, on the right side, the reddish violet here would make the color in the middle more brighter and more bluer, right? And on the left side, you could see how the color here would look like more reddish compared to the right side. So that is the very cool thing about perception and how the background colors would affect how you see the colors. All right. So that is your references. So, okay, do you have any questions for me? We have one more PowerPoint to go. Oh, it's 5:46. Na pala. Anyway, so let's continue this on next week. Sorry. Let's continue this on next week. So while we So on Friday, I'm going to give you an exercise about color. I'm going to ask you to draw or make a color wheel. But the color wheel that you're going to make is, I want an artistic color wheel and not just a circular color wheel. You can make a color wheel that is, what do you say? Creative color wheel. Like you could make not just a circular one, but different kinds of shapes, lines. That is up to you. All right, are we clear, guys?
Yes, po, ma'am.
Yes, ma'am.
Okay, so class dismissed and see you next week.